Go.
Okay, we have a series circuit and we're going to be finding E total, R total, I total. All of our voltage drops across our resistors. And then we're going to find the voltage A to B, voltage B, and voltage C to A. So the first thing we need to do is we need to find our E total. How do we do that? Well, we start in our upper left-hand corner. We go this way and we never look down and we're looking at our batteries. So the first one we come to is the negative, because the short side is negative, the larger side is the positive side. So we come to a negative 25 volts. We keep going, we come around, we hit the positive side of this battery, so it's a plus 25 volts. Keep coming around, the negative side of this battery, so it's minus 5 volts. Keep coming around, we hit the negative side of this battery, so it's a negative 10 volts. And we're back to where we started. So now we just algebraically add these up, and when we do, we know these two are going to actually cancel each other out, plus 25 to minus 25, so we're left with a minus 15 volts. Now, can our E total be negative? No, it cannot, so our E total is 15 volts. What does the negative tell us? That tells us we're going to go to one of our negative batteries, and that's the way we're going to determine which way current flows. So I'm going to use the 25 volt battery. Our current, we always leave the positive and go around to the negative. So our current flows clockwise. Now, once we have our current, that is our polarity. So we can put all the polarities on our resistors. And how do we do that? Well, we follow our current flow, we enter the positive side of the resistor, and we leave the negative side. And we just keep following the current flow around, going in the positive and out the negative until we get back to where we started. So we're in the positive, out the negative, and we're back to where we started. So now we need to find our R total. Well, how do we find R total in a series circuit? We simply add up all the resistor values in the circuit, and that gives us our R total. So we have 200 ohms plus 100 ohms plus 150 ohms plus 400 ohms plus 150 ohms. And when we add those all up, we should get 1,000 ohms. That's not how we want to see it. We want to move our decimal place 3 spots to the left, which means we're adding a positive exponent. So we got 1 exponent 3, that's 1 k ohms. So that's our R total, 1 k ohms. Now, how do we find our I total? Well, we use our nice little cheat sheet, Ohm's law, E over IR. We want I, we cover up the I, it's E divided by R. So we take 15 volts, we divide it by 1 k ohm, and when we do that in our calculator, we're going to get 0.015 amps. But that's not how we want it. We want to move our decimal place 3 spots to the left or to the right, which means it's a negative 3. So it's 15 exponent negative 3. Negative 3 is milli, so our answer is 15 milliamps. Now what I like to do is I'll come over here to my circuit, I'll put 15 milliamps, and I'll put it in a nice little cloud, and that way I know that's my current in the circuit. And it's a series circuit, so what do I know? I know the current is constant. So the current through this whole circuit is 15 amps, because it's got nowhere else to go. So the current through each one of my resistors is 15 milliamps. Now I want to find my voltage across my resistors. Again, I go back to my cheat sheet. I'm looking for E. I cover it up, and it's I times R. So I simply multiply 15 milliamps times 200 ohms to get VR1. 15 milliamps times 100 ohms gives me VR2. 15 milliamps times 150 ohms is VR3. 15 milliamps times 400 ohms gives me VR4. And then 15 milliamps times 150 ohms will give me VR5. So when I do this for VR1, I'm going to get 3 volts. 15 milliamps times 200 ohms. I'm going to get 1.5 volts for VR2. VR3, I'm going to get 2.25 volts. For VR4, I'm going to get 6 volts. For VR5, I'm going to get 2.25 volts. Now, since I know I'm going to need to be determining voltage from one point to another, I'm going to put all my voltage drops in a nice little box above my resistors. That way I don't have to keep looking back here. I can just look at my circuit. Put my little boxes up, and 3 volts, 1.5 volts, 2.25 volts, 6 volts, and 2.25 volts. So now I want to determine my voltage A to B. Now, the way I do that is I start at A and I go to B. And I add up, algebraically add up all the voltages from A to B. It doesn't matter which way I go. I can go from A to B this way, or I can go from A around to B this way, and I should get the same answer. I'm going to pick the easy way to go, A to B. So when I do that, from A to B, I have a plus 3 volts, because I come to the positive side of the resistor first, so that makes that a plus 3, and minus 25 volts. And I'm done because I'm at B, so I get a negative 22 volts. So my answer over here is negative 22 volts. Now I know you're saying, we can't have a negative voltage. You're right, but we are just measuring the voltage. I can measure a negative voltage. All that means is my leads are backwards from my voltmeter. It means I'm going against the polarity of the circuit. So how would I find voltage B? Well, anytime you only have one letter, it means I go from B to my ground or my common. Doesn't matter which way I go. I can go either way. Well, I went to the right that time, so this time I'm going to go to the left. So I start at B and I go till I get to ground, adding up all the voltages. First thing I come to is plus 25 volts. Negative 3 volts, so it's minus 3 volts. Come around, plus 10 volts. Minus 2.25 volts, and I'm at my ground. So when I algebraically add those up, I should get 29.75 volts. Because I have 35 positive and a 5.25 negative, so I get 29.75 volts. 29.75 volts. Now I want my voltage A or C to A. So I'm going to start at C. I can go to A this way, or I can go to A this way. Doesn't matter which way I go, I get the same answer. I'm going to go up. So I come to the negative first. Negative 2.25 volts minus 1.5 volts plus 25 volts minus 3 volts, and I'm at A, so I stop. So now I'm going to get here, I'm going to have 6.75. I take that away, should get 18.25 volts. And it's positive because my 25 was big. 18.25 volts. And that's all there is to getting our values for the series circuit that we had here.
Say goodbye.
Goodbye.